Hello everyone, this is Mr. Auble back again with another video, part 2 on the series of solving absolute value equations. The ones we did before were just trying to teach you the nuts and bolts of how actually to solve an absolute value equation. The problems we're going to go over today deal with two types. One is how to do an application, and within that application you might be asked to actually write an equation and then graph it as well. So what I thought I'd do is I'd start off with an example just like those we did on the previous video, but I'm going to take it one step farther. So the first equation that I see up there, number 1, talks about the idea that the absolute value of x minus 1 equals 6. So remember how we did this yesterday, or the last time we met, that we would have x minus 1 is going to equal 6, or we would say the opposite of x minus 1 would equal 6. And then if we solve each of these individually, we add 1 to both sides here. I'm going to write it down, even though I don't think you really need to see this work. But I'm going to write x could equal 7, or, now my first step here is to get rid of that negative, so I'm going to divide both sides by -1. And if I do that, I have x minus 1 on the left-hand side equals -6 on the right-hand side. And I'm going to add 1 to both sides at this point, and that will give me x has a value of -5. And now when I'm adding to this, I'm asking you to actually graph these. So I come up to the number line, I'm going to graph x equals 7, and I'll plot a point over here, and I'm going to look at x equals -5, and I will plot a point over there. So you're wondering, some of you are probably wondering, why can't the answer be x equals 7 and -5? Because if I look at that graph, you can't be at 7 and at -5 at the same time. You have to be at one place or the other. And they are both good solutions, but you can't be there at the same time, so we must use the word or. So what I would end up writing down as my answer is x equals 7 or x equals -5. Now what I want to do is I want to give you a quick introduction of what's going to happen on the next problem, because you look at problem number 2 right below it, you're actually asked to write an absolute value equation. And I want to show you how your solutions and the graph can go right to writing the equation. So the very first thing we'll look at is if you notice that you got 7 and -5 are the two answers that we came up with. If I find the mean or the middle between those two numbers, 7 plus -5 divided by 2 will give me the mean, and that actually equals 1. So my middle number is right here at 1. And then I look at it and say, oh, wait a second, how far is it from 1 over to 7? It's 6. And how far is it from 1 to -5? It also is a distance of 6. So those are not random numbers that just come out of nowhere. If you look back at the equation, that 6 is right here. Yeah, where I circled, because you notice that basically what we're saying is if we take some number, which we're not sure what it is, and we subtract 1, it's going to always, after we take the absolute value, it'll always be equal to 6. So that fits right into the equation. And then the second part that we look at this right here, we're saying if we take some number x, which it just so happens in our case, our x's were 7 and they were -5. If I take them and I want to find the difference between these two, right there in the middle is 1. So when I'm looking at my problem, I have 1 right up here. So what's happening here is that 1 will be the middle number, and the 6 will be the distance away from that middle number. So we can actually go ahead from the graph, find the equation very, very quickly, and you're going to be practicing that on question number 2. All right, on question number 2, I was going to have Ms. Vaughn do it, but she's actually getting her class started right now. So I'm going to go ahead and do number 2, and I'll have her come back and do number 3 in just a minute. So number 2 reads, write an absolute value equation whose solutions are -2 or 8. So if I plot my 2 points at -2, and my other point is at 8, and I want to find out what is that equation going to be. So just like I described on the last problem, I'm going to find the midpoint of my 2 solutions, and that's going to be part of my equation. So if I come here and I write 8, and I add -2, take the mean of those two numbers, 8 plus -2 is 6. 6 divided by 2 is 3. So my midpoint, which is not really a graph, it's just a midpoint, is going to be 3. So at this point in time, I have enough information to write my equation, but I'm going to actually do one more thing just to clarify it. The distance from 3 to the point 8 is a distance of 5. As you'll see, the distance from 3 to -2 is also 5. So what that means in writing the equation is I can now write my absolute value and say some number x, if I subtract 3 from it, will always give me a distance of 5. And it doesn't matter whether that number is 8, because 8 minus 3 has a distance of 5, because 5 equals 5. And also, if you go to the other solution, negative 2 minus 3, if you subtract those two, it also has a distance of 5. So that is correct as well. So my equation, which is x minus 3, the absolute value of it, equals 5, is the correct equation for the problem that you see.
Well, hi there. This is Miss Vaughn. I'm back. Mrs. Weber is in my room right now, so I was able to do number 3 for you. So we need to write an absolute value equation whose solutions are negative 10 and 4. So or 4. So the first thing we're going to do is actually graph our solutions on the number line. So here's your negative 10, and here's 4. Okay, Mr. Abel told you, or the previous example, you need to find the midpoint between those two solutions. So you need to take a look at negative 10 plus 4, divide that by 2, and you're going to get your midpoint. So negative 10 plus 4 is negative 6. Divide that by 2, so we're looking at a midpoint of negative 3. Okay, so I usually use a little x. Mr. Abel was using a dotted line. So either way, there's your midpoint at negative 3. So we know that it's going to be absolute value of x minus the midpoint. But if we're looking at a midpoint of negative 3, something's going to happen here. I don't know if you remember this from last year, but the cha-ching actually becomes a positive. So let's just rewrite this, x plus 3. Okay, so now where are we going to figure out our outside number? Let's take a look at negative 3, and we have to look at the distance to our two solutions. So you can count 1, 2, 3, 4, 5, 6, 7 units. And if you just want to double check, 1, 2, 3, 4, 5, 6, 7 units. So our distance is 7. All right, so our equation is the absolute value of x plus 3 equals 7.
Hello again, this is Mr. Abel, and I'm back. I'm ready to go through and try and go through a couple of applications. I'm going to do the number 4, and Ms. Vaughn will be here to do number 5 for you. So if we look at number 4, it states a thermostat is set so the temperature in a laboratory freezer stays within 2.5 degrees of negative 15 degrees Celsius. Write and solve an absolute value equation to find the maximum and minimum temperatures that are in the freezer. So I think what I'm going to do, I'm going to try and write this equation and try and figure out exactly what's going on here. So it looks like if I was to do it just for fun, I'm going to draw a little graph off to the side here. And I know that my goal is to be that little middle point thing, that little x that Ms. Vaughn was talking about. My goal is negative 15. That's what I'm hoping to attain. In a perfect world, my freezer would stay at negative 15 degrees Celsius all the time. But there's going to be some variation. And the variation that's acceptable is 2.5 degrees either direction. So it can go 2.5 degrees to the right, or it can go 2.5 degrees less, which would be to the left. And if I look at these numbers, then I'm actually going to figure out what those particular numbers are, just for fun. I think that's negative 12.5. And over here, that's going to be negative 17.5. All right, now just so you know, what I just did there really is not important to actually get writing the equation. All right, but it actually helps you solve the equation, but it's not important to actually write the equation. All right, so but let me go through and actually write the equation now. So we have a temperature that we are looking for, but that's not a perfect world. We're not in a perfect world. So this is the temperature that we're going to get, T. And I know that if I subtract the temperature that I want to have, negative 15, then I must be within a range of 2.5. So my equation actually will help me find the maximum and the minimum temperatures. So as Ms. Vaughn said with a cha-ching, You cannot leave minus negative there, so I need to cha-ching it. And I end up getting, instead, for my final equation, is going to be t plus 15. That absolute value will be 2 and 1/2, or 2.5. And as you've seen before with my actual picture, I mean, I could go through and solve it algebraically right now, or I can go back to my picture that I drew previously, and I can tell what I've circled in red, my minimum temperature is going to be negative 17.5 degrees Celsius, whereas my maximum temperature will be negative 12.5 degrees Celsius. And that, ladies and gentlemen, is the solution to this problem. I've written the equation, the absolute value equation of the absolute value of t plus 15 equals 2.5, and I found the minimum and the maximum values. And again, you could have solved it algebraically, but I already had the picture drawn, so that seemed to be good enough.
Okay, so let's take a look at number 5. It says that a brick company guarantees to fill a contractor's order to within 5% accuracy. Okay, so a contractor orders 1,500 bricks. Write and solve an absolute value equation. Well, it looks like the first thing we need to do is figure out what 5% of 1,500 is, because if we need to be within 5% accuracy. So remember, if you have 1,500 bricks and you want 10% of that, we move the decimal once, so 10% is 150. But we need to be within 5% accuracy, so let's cut that in half. 5% then would be 75 bricks. So we have to be within 75 bricks. Okay, so our goal is to get 1,500 bricks. So x minus 1,500 is going to be inside the absolute value bars. And we want to be within 75 bricks. So this is what our equation would look like. The absolute value of x minus 1,500 equals 75. So we wrote our equation, and now we need to solve it. Mr. Albo showed you graphically how to solve an absolute value equation by using the graph and looking at your midpoint and going from there. Well, I'm going to remind you how to do it algebraically. So we take the positive, the x minus 1,500, and set it equal to 75. And then we need the opposite, x minus 1,500, running out of room here, equals 75. So we solve our two different situations here, and this is a little or. Okay, so add your 1,500 to both sides. And we end up with a max here of 1,575. Then we go over to the other situation. And remember, this is multiplying by -1. So we're going to have to divide by -1. And we get x minus 1,500 equals -75. Add your 1,500 to both sides. And we get a minimum here of 1,425. So maximum number of bricks that you may get, 1,575. Minimum number of bricks, 1,425. And those are our two solutions. Make sure that when you write your final answer that you include the max is the 1,575. We need to understand that you get maximum means the most, and then minimum is your 1,425. So this is the best way to finish your answer here.